Rationalize each denominator and, if possible, simplify. We have an irrational number in the denominator with the square root of 5. Since there's two terms, multiplying by the square root of 5 will eliminate the irrational number here, but distributive property, we would just shift that irrational number to the first term. Rather, if we multiply by a form of 1 using the conjugate of 3 minus square root of 5, which is 3 plus square root of 5, in the numerator and the denominator, we will eliminate that irrational number in the denominator. And let's see how that works. So here's the special 1 that I'm going to multiply this expression by, which, as you see, is exactly the same as the denominator, only opposite sign. Multiplying then, 1 times the numerator is that quantity, and in the denominator, we have conjugates multiplied together. We can use FOIL method, but this follows the pattern of difference of squares, where we see that that middle term cancels out, and I'll talk through that right now. First terms multiplied together is 3 times 3. In other words, the first term squared. Outside, we would have a positive 3 square root of 5. Inner terms multiplied together is a negative 3 times the square root of 5, which cancel one another out. The outer and the inner are additive inverses and cancel out. And last terms multiplied, we have a negative times a positive is a negative, and we will end up with square root of 5 squared. There's that a squared minus b squared, the result of multiplying conjugate together. Simplifying this further then, in the denominator, we have 3 to the power of 2, or 3 squared, which is 9. A radical times itself is the radicand. In other words, the square root of 5 times the square root of 5 is the square root of 25, which is 5. And simplifying further, we no longer have that radical or irrational number in the denominator. Rather, we have 9 minus 5 is 4, and we've accomplished the mission of rationalizing the denominator, eliminating that irrational number that was there before. Here's another example, similar approach. The only way to get rid of that irrational number, since it's a 2-term, we will multiply by a form of 1, which is the conjugate of that denominator. So in this case, multiply numerator and denominator by the square root of 2 plus the square root of 3, the conjugate of the denominator. In the numerator, we have distributive property. We'll have 5 times the square root of 2 plus 5 times the square root of 3. In the denominator, we have our conjugates multiplied together. Multiplying first terms together, we have square root of 2 times square root of 2. In other words, that's squared. Again, just to illustrate, outside terms multiplied together, we would have a positive square root of 2 times the square root of 3. Inner terms, we'd have a negative square root of 2 times the square root of 3. These, when added together, are opposites and cancel one another out. And last terms multiplied together, a negative times a positive is a negative, and we would have square root of 3 times itself, or squared. Simplifying in the numerator then, our numerator has no similar terms, so we cannot combine, but in the denominator, square root of 2 squared is the radicand. Likewise, square root of 3 squared is 3. Simplifying, we now have a negative 1 in the denominator, and to clean up for a final answer, we'll divide both terms terms in the numerator by -1, since this -1 is underneath both of these terms. So we end up with a -5 square root of 2, positive divided by a negative. We'll call that a -5 times the square root of 3 for our final answer. And mission accomplished. There are no irrational numbers in the denominator.